time we have a hiker. Hiker travels uphill for 4 hours, going downhill the return trip. That there tells me with the return trip, I'm going to write that down, return trip tells me I'm going to have the same distance going up as we have going down. So the distance going up is equal to the distance going down. RT equals RT. Now I'm going to label here uphill and downhill so I can have my sides of the equation organized so they make sense for myself. Now I have uphill for 4 hours, that's the time uphill, and I've got the return trip taking 2 hours, that's the time downhill. The speed going down is 2 miles an hour faster, so if you're traveling at R on the first half of the journey, the downhill is going to be R plus 2. There's our equation. How fast are they going in each direction? We're going to do some distribution here on the right side. The left side is 4R. The right side is 2R plus 4. We don't have any like terms to combine, but we can subtract that 2R off of each side, giving us 2R on the left equals 4 on the right, and dividing by 2 on each side we get 2 miles per hour, which is the speed going uphill. And it was asking for the speed in both directions, so our other one is going to be R plus 2. R plus 2 is going to be the speed 4 miles per hour, and that will be going downhill. So in this problem we had a same distance. The problem before it we had a total distance. Now we have a problem that's totally different. This is a third pattern, and I'll help you determine how you know when to use this pattern. It takes 1.5 hours to go 12 miles upstream against a current. You can go 24 miles downstream with a current in the same amount of time. Find the speed of the boat in still water and the speed of the current. We're looking for two different things in this problem. What we're going to do is we're going to find two different distance equals rate times time equations. It told us for start that we can go 12 miles, that'll be a distance, in 1.5 hours. Well, when you're going upstream, you're pushing against the current, so you have your speed R minus the current that's working against you for 1.5 hours. The second thing says it can go 24 miles. That's a distance on our second equation. This time it is with the current, so you get the current working with you, R plus C, in the same amount of time, which is 1.5 hours. There are our two equations that we're going to work with. Now it turns out in ALEKS that you can always divide off the time. In each of these cases we're going to divide by 1.5. 12 divided by 1.5 is, we're dividing by 3/2, multiplying by 2/3, gives us 8. We're going to have 8 equals R minus C, and the second one is going to be 16 when you divide by 1.5 is equal to R plus C. Now we've got a nice easy equation or system to solve. The C's will cancel out. 8 plus 16 is 24 equals 2R, and you can see that R is going to equal 12 miles per hour. Pretty straightforward. We can find the other answer by taking that value of R. I'm going to substitute it right into the second equation. 16 equals 12 plus C. C must be 4. The water is going at 4 miles per hour in this problem. Okay, let's do another one of these. We've got a plane flying 720 miles with the wind in 3 hours. The return trip takes 4 hours. What's the wind speed and the speed of the plane? So we're looking for two things, the plane speed and the wind speed. That's the clue that we're using this method here. 720 is the distance this first time, It's going with the wind, so we're going to have r, the current of the or the speed of the plane, plus the wind giving us a boost in 3 hours. There's our time. The return trip, that means it's the same distance, 720. This one is against the wind, r minus w, takes 4 hours. Very straightforward setup. Now, I'm going to divide by the time there. In the first equation, I'm going to divide by 3. In the second equation, I'm going to divide by 4. And 720 divided by 3 is, just lost it, 240 is equal to r plus w. And dividing by 4, we're going to get 180 is equal to r minus w. Adding down the two equations, the w's cancel. We're going to get 420 is equal to 2r. Dividing by 2, we're going to get r is equal to 210. Again, this is miles per hour. And I'm going to substitute into the top equation there. 210 plus what makes 240? That would be a wind speed of 30 miles per hour. So it doesn't matter whether you're dealing with the stream with the current, the wind with an airplane, or the third pattern that you might see is a moving sidewalk. The sidewalk, like in an airport, can either give you a boost or it can slow you down, and you'll be subtracting in that case.